Looking to earn PDH credits for watching this webinar? Please log in to SFP's e-learning platform and select this webinar. Earning PDH credits for this webinar on this platform are free for SFP members, but non-members will be charged. If you're just looking to listen or share information on fire protection engineering, feel free to continue with videos here.
Hey, thank you to everyone on the web for joining us today. This is Chris. We are excited to present some of our experiences with BIM to show you how to leverage this technology in your practice. So for today's learning objectives, we're going to differentiate between two popular BIM software tools, articulate at least 4 benefits and challenges of using BIM design as compared to traditional design methods. We will also describe how BIM design can be used for sprinkler design, fire alarm design, and code consulting. So on our agenda today, we will review the available BIM tools that can be purchased by fire protection engineers, the benefits and challenges of those tools. Then we'll review case studies in depth to share how Henderson uses BIM to enhance our designs and consulting services. Finally, we'll conclude with a detailed demonstration of the Revit add-on Dynamo. So first off, let's talk about BIM. What is BIM? BIM is an acronym, stands for Building Information Modeling. BIM is a digital representation of the physical and functional properties of building components. Component information is stored in database-like format that allows for a myriad of different representations. And one of those is a 3D graphical computer model that we can use to visualize a building. That's what you see on the pictures here. The predominant software in the market is Autodesk Revit, and another commonly used tool is SketchUp. In our experience, the main difference between these is that SketchUp is primarily a 3-dimensional graphics tool, and Revit is a 4-dimensional graphics and information management tool. The 4D, or 4-dimension, refers to the ability to design for different project phases. You'll notice that there is a little add-in there for HydroCAD for Revit. We will talk about that in more detail also. Henderson started using BIM in 2007 with the University of Oregon's Matthew Knight Arena, their basketball arena, and that's shown in the screenshot at left. The screenshot on the right is one level of a full fire sprinkler design for the LA Rams new stadium that we're also working on. BIM is currently used on about 40% of all of our projects, large and small, and this is up from 20% of our projects only 2 years ago. So we're seeing tremendous growth. How we use BIM is a number of different ways. I mentioned sprinkler design, where we can coordinate with other building systems. We use it for hydraulic calculations. That was the add-on HydroCAD for Revit. We can use it for stock listing of components. We don't typically detail every fitting to that level, but we could if requested by the client. We do fire alarm device layout, and the benefit there is that the device is attached to walls and ceilings. So if the walls and ceilings move, the devices move too. So we don't have to go in and redraw it. Finally, we can export models to PyroSim and FDS. The screenshot you see here is from SmokeView of one of our modeled fires from an arena project. Now, you might be wondering about some of the benefits. Why would you want to waste your time learning this new tool? Well, there are a number of benefits. One, and the most obvious one, is visualization. It's really helpful for owners, and I'll say lay people, folks that aren't engineers and architects, to understand how a building is configured, because you're seeing it in 3 dimensions versus 2. It really helps with coordination between trades. That is very helpful for the owner, and that hopefully you're receiving fewer change orders due to conflict. And it goes a little bit deeper into design rather than just performance design for fire protection engineers. It helps with cost estimating accuracy, and that you know the exact quantity of materials versus just a generic dollar per foot. which should result in tighter bids by your contractors. You're going to get a true apples-to-apples comparison between the bids. Construction materials tracking is much more easily handled because the manufacturer and model information is captured in the BIM families. And we'll talk a little bit about more about the families later on as well. But those are unique to vendors, for example, and they can contain additional information. It's similar to a CAD block, but the depth of information is much greater. Finally, you can customize the data manipulation using Dynamo visual programming. We're going to go into that a lot deeper and further into the presentation today. The screenshots on this slide show some of that information from Dynamo. One of the other benefits of BIM is demonstrated by this curve. So traditional design, engineering, construction, and then life cycle management are represented in these four sections. They're subject to a kind of a sawtooth process, as shown by this green line on the bottom. And as information passes from one team member to the next, meaning from architect to engineer to contractor to owner, the knowledge and understanding of the facility is lost and has to be relearned or learned by the downstream teammate. BIM changes that. BIM allows each team member to collaborate on the facility simultaneously, which should theoretically result in a higher quality, lower cost facility compared to traditional design methods. Now, there are some challenges with BIM. There are some drawbacks. The first one is that we can't sign and seal it. You can't construct off of BIM directly. Current laws require construction documents to be 2D, paper, or PDF format, signed and sealed by the engineer of record. I can't currently sign and seal a model. There's a learning curve involved. BIM involves more data. It involves a third dimension. In many respects, that curve is steeper. Luckily, for the software developers have continued to evolve and improve the tools since 2007. Back then, it was a lot more difficult, and they've tailored our interfaces to replicate the tools that are more familiar to us, such as AutoCAD. Jason's going to talk a little bit about that in his presentation to show you how similar those tools are today. The technology limitations. Now, you can run Revit on an entry-level PC with a single core processor with 4 gigabytes of RAM, 5 gig hard drive that runs off platters, and a single monitor. I don't recommend that. Your team might rebel against you if you choose to go that route. We use 16-core Intel chips, at least 16 gigabytes of RAM, usually more, 256 gig solid-state hard drives for very fast upload-download of information, video adapters with shader model 5, multiple monitors, et cetera, et cetera. So there's a cost that goes with that, of course. So what you have to determine is the cost of that computer worth your time? And until you get into the process of using BIM, you may not be able to evaluate that very well on your own. We have learned that through trial and error here. We have found that the computer cost is somewhat minimal as compared to labor. So that concludes my part of the presentation today. But I did want to mention, before I pass the control to Jason, I wanted to fully disclose one item, and that is that our IT group is amazing, and a technical glitch is really unlikely. But we have recorded all of the BIM actions that you're going to see as videos and inserted them into our PowerPoint. The videos are shown in real time, and they're not edited, but we just wanted to make sure we didn't have some technical glitch inhibit our webinar today.
Thanks, Chris, and welcome to Revit. As you can see, the Revit interface is similar to AutoCAD. We have actually the quick access toolbar, information center, of course the drawing area, a properties palette, but the big differences between the two are the project browser. The project browser is basically the navigation palette to the model. even though the interface appears to be the same, there's a world of difference between the two. The key difference is Revit stores information. One of the ways Revit stores information is with the use of families. Modeling requires families. Families are the heart of all Revit designs. However, some families only store limited information. One of these families is pipe. Little information is put in the model or in the family. Another one is pipe fittings. A little bit of information in the family, but a lot of annotation information. And another one is, of course, our sprinklers. We include a lot of information in our sprinklers to actually populate systems. So actually, let's look at a sprinkler family real quick. So when I select this and I go to Edit Family, I'm actually opening up the second portion of Revit. Revit is actually two systems or two programs in one. It's a modeling program and it's a family editor. The family editor is where we can add information, and primarily the information is stored in what we consider parameters. Parameters can help us with scheduling, to cost, to who is actually responsible for purchasing the sprinklers. Again, all the information is stored in these parameters. One of the things that I want to show is the sprinkler actually has the cut sheet linked in the family. So what I want to do is, on a parameter of cost, is I want to add just a random dollar amount for installation for this one sprinkler. The benefits for the EORs are that most manufacturers actually already have these families built. So sprinklers, fittings, backflow preventers, fire pumps. You can imagine the amount of information that's stored in that family, and even our simple flow switches. And additionally, all of this information can be stored in our schedules or populated in schedules. Schedules are intended to help the ease of speed of producing documents. For instance, if a sprinkler is added to a system, Revit can populate a sprinkler schedule, as shown here. Remember, we actually added the cost to that one family. I want to actually add that cost into the schedule. We want to figure out how much is going to cost to populate or actually install this system. So I'm adding cost, and I'm also adding a quantity. Now, when Revit populates this information, it's actually going to give me a price per unit. I need to change that to show total. So I'm going to go into the schedule, give Revit a field condition or field formatting, and now it actually populates a price. The schedule was actually already populated, so I want to show you how it actually looks like on the sheet itself, which is shown here. If you notice on the left-hand side of the schedule, it actually populates a symbol. That symbol is actually inside the family. And of course, we don't want to give this information out to the contractor. This is just internal information, so I'm going to go back in and remove that information. The design is now complete, so how can Revit help us coordinate? Revit can perform some interference checks. Most know this is, of course, clash detection. Revit already knows where the interferences are. We just need to run the report. So what I want to do is I want to run a report between pipes and ducts. Now, Revit sees pipes as any pipe in the building. It's not necessarily looking for the sprinkler pipe. So I know I have an issue in the store. I'm going to actually scroll down, select the issue, and it tells us exactly where the issue is. If you can't see it, actually it's highlighting the duct If I go over and select the pipe, it's going to highlight the pipe. If I don't see it in the screen, I'm going to actually ask Revit to show me where it's at. Zoomed in, shows me where the issue is. Also, as you can tell, there is IDs associated with the duct and the pipe. So every item that is placed into the model has a certain ID for every single product. Interference checks can be run on any component in the model. Your benefits for running interference checks is time savings. When coordinating, example, if coordinated with structure, you can catch your interferences prior to installation. There's also cost savings when you're coordinating with other trades, as shown here. Studies have shown about 35% of construction cost is wasted on errors and mistakes. Revit is not necessarily the fastest way to design, but it's one of the smartest ways too. Revit can aid us with a smart design approach. So some of you may be asking at this point, what about calculations? Can Revit do hydraulic calculations? Yes, they can. However, we would suggest third-party add-ons for now. Third-party add-ons can aid in your design. Some of these third-party add-ons have their own hydraulic calculations programs that can be linked into Revit, as shown with this HydroCAD toolbar. These programs have their own set of ribbons and functions inside Revit, similar to what is being shown. Another program that's out there is AutoSprink, which again gives the user additional functions and also can perform calculations. All third-party add-ons enhance the user's experience. BIM 360 design. Another piece of the smart design is cloud-based models. Autodesk has created such a place. The BIM 360 is a construction management software that utilizes Revit. This is a big point here. The model is cloud-based. So all of your updates are live and without file transfers. Also, the additional features for your overall construction management, BIM 360 has. You have RFIs, coordination, changes, etc. Cloud sharing in general is gaining popularity among architects, and we are seeing much more projects going in this direction. BIM is a powerful tool that can save you time and money. Less time spent in the field coordinating with other trades. As you've seen, it's much more than just a drawing. It's information, it's coordination, can produce cost analysis, construction document. It houses all of your building information for a fully coordinated building prior to construction. Also has live updates. Additional features that I did not cover is it can phase your project schedules, work sharing, which allows multiple designers in the model at one time, and it also gives a visual check for designers. And lastly, it reduces human error. At this point, Ryan Holmes will now introduce you to the power of Revit and code consulting.
Thank you, Jason. Yeah, I'm going to talk today about how BIM can be used for the code consultant. Unlike Jason, their code consulting doesn't have anything native built into Revit, and so everything we produce is on an annotation level. So there's nothing we can really take from out of the box Revit that gives us the benefit of actual parts. So some of the benefits we have for Revit is increased productivity and efficiency. All the information, all different types of information can be stored within Revit. Revit is a database. If you take away one thing today, just know that Revit is a database. And with that database, you can perform functions and calculations that will increase your accuracy and reduce the level of human error that you can bring into your model. With that, it's abundantly customizable. We can create whatever families we need to how in the way we want to show to our clients and how we want to accurately calculate occupants or plumbing fixture counts or anything that is valuable to you in that moment. There's also new and exciting tools across multiple disciplines that are being developed every day. Here at Henderson, we utilize Revit primarily, but there's many add-ons that we've created and we employ across multiple disciplines. And Dynamo for Revit is something that we have been using here at Henderson for a little bit. Some challenges we face, there's a lack of out-of-the-box tools designed for the code consultant. That means we have to be creative with how we design families to display the information we want to show. Just because there isn't a default way doesn't mean you can't create a way. There's also limited technical experience with design professionals. Project managers aren't always informed on how the software works, so there's kind of a knowledge gap there when it comes to what can be done and what can't be done. And it's just some communication needs to take place in order to demonstrate what can be shown on your documents. And with that, there's not very many BIM standards when it comes to consistency across the board. Companies typically keep their co-consulting practices in-house, and so there's not very much the sharing of knowledge across companies, so that's kind of a challenge. And with that, there's complex Revit families. In order to get Revit to do what you want it to do, you have to be willing to manipulate families and think creatively to create different families. How it's been used with co-consulting? Primarily, we here at Henderson use it for egress plans. Egress plans are a way to demonstrate packing a building full of people and then egressing them safely and preserving life. This is important when doing large assembly projects like stadiums and arenas to demonstrate that people aren't going to get stuck in an event of a fire or a life-threatening event. Another way we use it is smoke modeling. That's another form of life safety. It's a good way to visualize a real fire that's going on in a building. What we do is, with the BIM model, we export it and it has information applied to it. We can export it to a third-party software that allows us to run theoretical fires and create and design smoke control systems. We also use BIM for statement of conditions work. It's ideal for BIM because it's a database. So information that is stored from information that's been documented from a hospital or an actual conditions of a hospital can all be stored in the Revit and be queried whenever it's needed. Another thing we do for our clients, whenever just something fun, is plumbing fixture calcs. This information is typically done by the architect, but sometimes they like reassurance that they have the right required amount of fixtures, and so we're just here to help them show that kind of information. So typically for an egress plan, before we have Dynamo, occupants are calculated by dividing an area by an occupant load factor. So here in Henderson, we use areas and we have to draw area boundary lines. This takes up a bulk of our time, and then after that, you have to place areas, and then you have to divide the number by an occupant load factor, and then you put it into a text tag. This is just a really inefficient use of our time, but this is what can be done. After that, you would have to designate the exits, and then you have to demonstrate how you can distribute people evenly and accurately throughout the model. So you have to grab your calculator and manually calculate the clear width of each exit, and then grab it again and divide all of your occupants evenly, and this is just an inefficient use of time. So we put our thinking hats on and came up with some Dynamo tools that will allow us to get rid of all the inefficiencies and allows you to eliminate the tedious process of data entry, something you do every single time you do a new project. So remember how I said we need to create area boundary lines? Well, we've created a script to significantly reduce the amount of time it takes to place area boundary lines on a drawing. So the only information you really need is what level you're working on and what view you'd like to see these lines placed on. And if you hit run in manual mode, it will place these lines for you. This drastically reduces the amount of time needed to model an exit study. Some families that we use in Revit, all the families we've created have calculated values in them. And there's a mixture of of formulas and a mixture of information from tables and model information. If you look on the left, that table you can find that in table 1004 in the IBC. It's just the occupant load table. This is information that's stored within Revit, so you don't have to manually enter in numbers and do calculated numbers. I can teach my families to pull information from this to give us an accurate number every single time. And if you go to the upper right, there's an example of an area tag. The top left corner is a calculated value, and the top right is a value from that table on the left. And the bottom square is from the area in the model. So now we have all our area boundaries placed. We can drop a few areas here, just kind of give you an idea of how Revit is calculating area. And so, we have a few different occupancies here, or different types of occupants in here. We have library, we have assembly and concentrated, we have some educational. I'm just going to drop a few here to show exactly just different types of occupancies to show how Revit's calculating. By default, the occupants are not calculated because I do not have Dynamo turned on by any means. I just want to show you the process, but by default, only the area is being calculated. This is producing a schedule, and with that schedule, you have to go in and manually change all of these areas just so your tags can represent what's being shown in the schedule. This is great if you have 6 areas like I do here, but if you have an arena that has 200, 300 areas with constant model changes, this can get tedious. And so if you look right here, like let's say this area changed to an assembly unconcentrated space, well, the tag wouldn't update. I'd have to go to the schedule, and it would tell me which one is wrong, but this introduces some error, potential error, if you don't remember to check this every single time. And with that, we could drop in some exits here. So right now you're seeing a family that controls a non-smoke protected exit. And this is right now we're saying, okay, we're going to look at the stairs. So in this case, we have 2 stairs, and we can manually control the clear width. By default, there's some annotation that shows up that says this exit doesn't work because we want to be able to check this as designers, make sure we're actually looking at these tags and whatnot. But this is the process before we had Dynamo. So you can see the capacity of this door is 160 occupants, and we have 600 going through it. Well, it's broken, so you can't do that. But if I change the stair width, let's say 5 feet, my capacity changes. And if I change the 600 to, let's say 0, now that annotation for it being broken disappears, and at 200, it's not there. But if it goes over, it shows back up again. So that now comes into our Dynamo script. So we've developed this script to cut out all of the data entry that you would have to do on an exit study. So that you can kind of get a glimpse at the scale of this thing. There's quite a few nodes, but this has all been trained to just eliminate the entering of the occupants and the square footage into that tag. And if I hit run on this, it will, in theory, run all of these accurately. So you can see among all of our exits, everything's been distributed equally based off of clear width. If I come in here and I change the clear width to say, let's say 6 feet, it's going to redistribute evenly across these exits. And so let's say the architect comes back and says, oh, hey, this room is different. All we have to do is manipulate and change the area boundary line. The calculated occupants will then change. It'll automatically calculate right there. And let's say we go over here and this needs to be 7 square foot per person. So we come down here to our function, we change our function of the space. And if you watch the exit tags, they will automatically redistribute occupants evenly. The makeup of an egress component. Within all of our doors, there's a bunch of formulas and custom built families and information that is trained to do the math that you can do with a calculator. This is all stored within Revit in this database function. And this is one of the greatest tools because we can just store information here and query it whenever we need to. In this case, like if we had a smoke protected or non-smoke protected assembly, we can change these exit width factors, and the exit tag will then calculate capacity differently. One thing that's really cool about Revit is schedules. Granted, I have people in here, but I don't physically have any objects, but I have a number, and I've taught my schedules to, hey, look at this number. So the occupants change here, and you can see the total number of people it's always accurate. It's always counting who's in this model. And this can be broken out by level, by building type. You can customize your schedules however way you want. And to show exits, I'll clear this out to show you that it will always have the number of people exiting out of the building. It'll be the same as the number of people in the building. So you can watch these tags populate, and then we'll go back to the schedules to show you that, hey, look, 413 people are exiting the building, and we have 413 people that are actually in the building. So this eliminates the punching on a calculator and making sure you have people going evenly to the right amount of doors. We can change the clear width to give architects, help them solve some solutions for exiting people. This is meant to be fluid, so we can be creative with our clients. Some other tools that we use, we do some nice things with plumbing fixture counts. All this information can be found in Chapter 29 of the IBC. Once again, it's stored in Revit. It eliminates having to go to a third-party software like Excel or any other hand calc or any other program you'd use to calculate plumbing fixture counts. All this is built into a Revit family. This is something that we do just to once again give the architects some peace of mind that they have what's required, and so this is just something we can throw onto sheets quite easily. Now this is just a demo of how the family actually works. So in this case, it would be occupancy, and right now it's calculating according to the requirements will be occupancy, assuming a 50% distribution. So all we need to do here is come to change 300 people, and these fixtures will update, and it will be accurate, and we'll just drop on our sheet quite easily. And this is a tool that we can just easily create different plumbing fixture counts for.